Hi friends, we are covering the Terraform infrastructure as a code tool. The first video we covered basics, what is what. In this video we will cover the types of IAC tools. What are the types of IAC infrastructure as a code tools are available and used in the large scale corporate. So we can classify IAC tools into three categories. The first category is called configuration management. Ansible, Puppet, and Saltart. These three tools comes under configuration management. The second category is server templating. Docker, Packer, and Vagrant. These three tools comes under server templating. The third category is provisioning tools that we are going to study in this series. That is Terraform and CloudFormation. So all the ISA tools can be classified into three categories: configuration management tools, server templating tools, and provisioning tools. So if you want to try job in large scale MNCs, you should you should have worked in or you should have knowledge in these tools. The first category is configuration management tools. This Ansible, Puppet, and SaltStack. This comes under configuration management tools. The primary focus of these tools are installing, configuring, and maintaining the software on existing servers. So these configuration management tools will manage the internal state of operating system and ensure that application, package, configuration, and security policy are applied consistently across multiple nodes. For example, if you are managing 500 servers in Azure Cloud or AWS GCP, so if you want to manage them consistently, all the VMs should have the same OS version, should have the same application package, configuration, everything should be same in all the 500 nodes. In that case, we can use these configuration tools, Ansible, Puppet, and SaltStack. So they will help to maintain the uniformity and present configuration drift over and prevent configuration drift over the time. If you look at the Ansible, it is a agentless architecture based on. So Ansible is based on agentless architecture. That means we don't need any agent to manage the all the 500 nodes by using Ansible. The Ansible helps us to automate the task through YAML based playbooks. So this Ansible communicate with the remote system primarily through the SSH in Linux and WinRM in the Windows machine. Ansible is lightweight and easy to deploy because no agent is required on managed nodes. So Ansible is the most popular configuration management tools. Puppet. Puppet is a declarative domain-specific language tool (DSL) to uses the DSL to define the desired state system. It typically follow a master agent architecture, that is master client server client architecture. So the Puppet, with the help of agent, it continuously check and enforce the desired state configuration on the managed systems. So this Puppet is well suited for maintaining consistent system configuration across the large environment. So if you look at the salt stack, it uses an event-driven architecture for automation and configuration management. It supports configuration definition using YAML file and is primarily implemented in the Python. To provide fast remote execution and automated configuration management, particularly useful when rapid communication and large scale automation are required. So these are all configuration management IAC tools. So how these configuration management tools works in Azure? These configuration management tools in Azure used to install, configure and maintain software and settings consistently across all the Azure VMs. For example, the scenario is you have 10 Ubuntu VMs running web application in Azure. We have 10 Ubuntu VMs running in Azure. These 10 Ubuntu VMs hosting web application. So you can use the Ansible to install Nginx in all the VMs, configure firewall rules, deploy application files, install required packages, start and enable the services, maintain the same configuration across all the VMs. So we deploy the 10 Ubuntu VMs using Terraform or Bicep by using provisioning tools. So when the resources are provisioned created in the cloud, we have to configure it. So we will use Ansible to configure. For example, if you are managing 500 web servers, which need the all the 500 need the same setup, same configuration, same package. So in that case, we can use Ansible to configure all the systems consistently, uniformly. So if you look at the configuration files, Ansible configuration files, name configure Azure web servers, host web servers, and then the Ansible configuration. This is the install Nginx, start Nginx. So with the help of Ansible, we can configure the 500 thousands of VMs and manage it consistently across the entire Azure cloud. Puppet is another configuration tools. For example, if you have 500 or 50 Azure VMs, that must all have the same security and application configuration. So we define the desired configuration, that is security and application settings or configuration. So what it will do? The Puppet will ensure that all the 50 Azure VMs Nginx is installed, a specific configuration file should exist, and required users and groups are created, security settings are applied, services running. So we define this desired configuration in the Puppet file. The Puppet agent running on the Azure VMs periodically communicate with the Puppet server and ensure that the VMs remain in the desired state. The third configuration tool is salt stack. For example, if you have hundreds of Azure VMs and need quickly install a security package or restart a service across all of them, we can use a salt stack. So we define the settings configuration in the salt stack files configuration file. It will be implemented across all the hundreds of VMs. So we deploy VMs in Azure, AWS, or GCP using provisioning tools like Terraform, Bicep, or cloud formation in AWS, and then we can configure all these VMs by using configuration tools like Ansible, Puppet, and SaltStack. The second category of ISC tool is server templating. In this category, the primary focus is pre-packaging the lightweight container environment or virtual machine image before deployment. So instead of repeatedly configuring the live servers, server templating create a predefined and reusable environment containing the operating system, application dependencies, configuration, and application code. This once we created the artifact, this artifact can be used to deploy a consistently across a different environment. Usually, we will first deploy it in the dev environment, test it there. If it is working, then we will move into QA environment or staging environment. Then, if it is working there, then we will move into the prod. So, if you want to consistently deploy the servers with the same OS, same application dependency files, configuration, application code, we can use the some server templating ISA tools. In server templating ISA tools, we have three tools: Docker, Packer, and Vagrant. For example, if you look at the Docker, the company has a web application that needs Node.js application code and specific libraries. Instead of installing this manually on each and every VM, the Cloud Ops team will create a Docker image containing everything the application needs. So they will create a Docker file, define everything inside the Docker file. Then they will create the Docker image can be deployed to Azure services such as Azure Container Apps, Azure Kubernetes services, or Azure Container Instance. So once we create a Docker image, we can deploy the Docker image multiple times, multiple instances in the Azure Container Apps ACA, Azure Kubernetes Service AKS, and Azure Container Instance ACI. So Docker is a server templating tool. So next one is Packer. A company needs 50 Azure virtual machines with the same operating system, security update, monitoring agent, and application software. Instead of creating each VM and configure it manually, Packer can create a standardized Azure VM image. Like image can contain Ubuntu or Windows Server VM, OS, security update, Azure monitoring agent, record application package, company specific configuration, and record dependencies. So all these they will create an image. The image can be used to create multiple VMs. So Packer is one of the server templating tool. The third server templating tool is Vagrant. So developer need a reproducible development environment that is closely resemble the company's server environment. So we can use the Vagrant to define a VM environment using the configuration file called Vagrant file. So in that file, the developer can define the operating system, CPU and memory, network settings, software packages, development dependencies. So Vagrant is primarily used for local development, but can also used in the cloud providers. So Docker is the containerization tool. So Docker is the It is a package on application and its dependency into a container and apply to the Azure Container Apps or AKS. Packer is a create a standardized Azure VM image that can be deployed in multiple VMs. So VM image creation. Vagrant is create a reproducible VM based deployment environment. So if you look at the real world example, the Docker it packages the application, that is Node.js libraries dependency into a container and deploy into the Azure. Packer it creates a standardized Azure VM image containing everything, including OS, server updates, monitoring tool, and everything. And we can use this image to create hundreds of VMs. Vagrant gives developer a reproducible VM environment. So this is second category, server templating tools. The third category is provisioning tools, that is Terraform and CloudFormation. The primary focus of provisioning tools is building, updating, and destroying the infrastructure component. So we can deploy servers, apps, PNet, all the cloud resources. We can update the cloud resources and we can delete or destroy the cloud resources. So the provisioning tools are used to create and manage the core infrastructure required by the application. So with the help of provisioning tools, Terraform, CloudFormation, Bicep, we can able to deploy virtual machines, virtual network, firewalls, load balancer, databases, storage, and other cloud sources. So instead of manually creating these resources through the Azure portal or AWS console or GCP console, we can define all the resources in code files and deploy it by using CI/CD pipeline. So if you look at the Terraform, a company need to create an application environment in Azure containing resource group, virtual network, subnet, network security groups, virtual machine, and storage account. So instead of manually creating each resource in Azure portal, we can define all the resources in Terraform configuration file, and we can define all the resources in the Terraform modules, Terraform files, and we keep these files in the GitHub repo, and then we will deploy through the CI/CD pipeline. So Terraform will compare the desired configuration with the state and determine what needs to be created, changed, and removed. For example, if you are creating a new environment, no issue. If you are deploying resource in the existing environment, some resource will be already created. So we have to either modify it or we have to ignore it. So the typical workflow is first we have to create the Terraform code in configuration files, Terraform files. Then we have to initialize it, we have to plan it, review the changes and apply it. Finally, if it is no longer needed, we can destroy and delete the resources. So Terraform is a multi-cloud platform tool. So we can use this Terraform module to deploy resources in multiple cloud environment. So next class we will cover this declarative and imperative types of ISCs.